Chapter 6, Lesson 1, the polygon angle sum theorem. So the objective today is to find the sum measures of interior and exterior angles. It's kind of like what we've already done in class. So key things when I'm looking at here, equilateral polygon, equal angular polygon, and regular polygon. Now we've had equilateral, equal angular triangle. So basically what these two mean is that when I'm using the polygon, all sides are equal, all angles are equal. That's what the equilateral polygon, that's what an equal angular polygon means. So basically any shape that I'm talking about. A regular polygon means that all angles and sides are congruent. So any type of shape that has all angles, all sides congruent would be called a regular polygon. Those are the three types of things. So if it's regular, it is both equilateral and equal angular. So the names that we give to polygons, if you don't know these off the top of your head, I would pause this and write this all down. However, if in class, if I say I have a heptagon, and if you know that that has 7 sides right off the top of your head, I would not write that down. But if you need a reference to go and look back at, I would write this down. So we have two different equations here. This first equation is when I'm looking for the total sum of a polygon. So all the angles added up together in a polygon. This second equation here, as you can see, it's a lot like the first, except it just has this extra divide by n here. That's when I'm looking for each angle measure in a regular polygon. So meaning if I had a regular heptagon, I would want to know what each angle is equal to. So I would do 7 minus 2 times that by 180 and then divide by 7. That would give me each angle in the regular heptagon. So my first problem, what is the sum of the angle measures in a tengon? So it doesn't say anything about regular. If it never says anything about a regular, because it's just asking for the sum of the angle measurements, this is the equation that I'm always going to use. So my n is equal to number of sides. N is equal to sides. And in this problem, I have a tenagon, so I'm going to replace that with 10. So n is 10. So I have to do 10 minus 2, which is 8, and 8 times 180 is equal to 1,440 degrees. So if I measure each angle in a tenagon, I would get 1,440 degrees. Marcy creates a floor tile pattern using squares, regular hexagons, and irregular dodecagons. What is the measure of each angle in one regular dodecagon? Before I get into this, square is a regular quadrilateral because all angles and all sides are congruent. So that's just a shortened version of the regular quadrilateral. So I'm talking about what is each angle, when that's key here. If it's problem says each angle and regular, that's meaning I'm looking for this equation. Because this right here will give me my total measure, and then I have to divide that by how many angles I actually have. So in this problem, in a dodecagon, n is equal to 12. So I plug in my equation just like that, and 12 minus 2 is going to give me 10. So I have 10 times 180 divided by 12. So I have 1,800 divided by 12 is going to be equal to 150 degrees. So this right here would be my final answer. Each angle in my dodecagon, so this angle right here, is 150 degrees. So what is the measure of angle D? Well, first I'm going to label X at angle D, because for me personally, I always like to have a symbol that I'm looking for. And it's saying a quadrilateral. Quadrilateral has 4 sides, so I'm going to use my equation n minus 2 times 180, and I'm going to figure out what's the total measure of a quadrilateral. So I have 4 minus 2 times 180, and that's going to give me 360 degrees. This is my total. So now I can write up an equation. Because I have 4 parts, 1, 2, 3, 4, and my total. So I can have 91 plus 98 plus 112 plus x is equal to my total measure, which is 360. So if I combine my like terms here, 91, 98, and 112 would give me 301 plus x. So if I want to get x by itself, I'm going to subtract 301 from both sides of my equation, and I get x is equal to 59 degrees, which is also equal to the measure of angle D. And my last problem, exterior angles. You should have figured out that whenever I have exterior angles, the sum of my exterior angles is always going to be 360. Always, always. So what is the measure of an exterior angle and a regular keyword there, hexagon? So I'm looking for this angle right here. If this angle right here is the same as this, 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 that means all of these angles here that I created equal 360, and there are 6 sides because it's a hexagon. So I can do 360, because that's my total of my exterior angles, divided by how many angles I actually have. In a hexagon, I have 6 angles. So this would be, each of those angles that I drew there would be equal to 60 degrees, which is also equal to measure of angle 1. So it's very important to remember, no matter what, 360 is my total measure for my exterior angles. As your polygon increases in sides in a regular polygon, this number is going to decrease. So make sure you fill out the Google Doc and submit it. Have a wonderful evening.